Now this is a very interesting vacuum tube. It started life as a 6199 photomultiplier tube. Now this is what's called a head-on device. So it's looking for radiation on this surface of the flat glass that has been obscured by this ring of epoxy. The way a photomultiplier tube works, this curved portion is actually the flat portion on the front of this tube. If it's struck by a photon or an alpha or a beta particle, light or radiation, it might emit an electron. The electrons are attracted by these diodes, and it bounces back and forth, and hopefully it gets faster and faster in its bouncing, and it also, one turns into 2 or 3, 3 turn into 9 or 20, bing, 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 bing. So final bounce is to P, the anode, or the plate. It's a P here, it's an anode here. Here's a 5 to 1000 volt regulated power supply. Negative sides of the power supply connected to the flat, even though it's curved, cathode. It's not heated. It's excited by light or high energy particles. There's a voltage divider connected across the power supply. Typically 91,000 ohms apiece. Bing, 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 bing. So that you can see the voltage rises in steps. Here to here, it's the power supply voltage divided by 11. 11, 1/11, 2/11, 3/11, 4/11, and so on. The electron is attracted to that positive voltage, hits a sensitized plate. It and a few of its friends leave the plate and travel so forth. These diodes are all one higher voltage than the other. The final group of electrons, one multiplied by many, many, many bounces, finally leaves diode 10, is collected on the plate and sent out to a load connection. The load is a current measuring device, either just a simple meter, a milliammeter, or some analog circuit that does something. In response to the cathode being impinged upon, RCA produced this tube where all of this is glass, even the face. Picker Corporation, they're either out of business or had been absorbed, probably intended this to be mounted this way. Or this way, not sure. And radioactive source stuck into it. It's probably mounted into a case, fancy, expensive electronics. This is a cesium-137 standard from New England Nuclear. This device, Picker Corporation made, could be standardized with something like this, and then glass cuvettes like test tubes, but very precision made, with radioactive liquid solids or gas could be stuck in here, and the radiation could be precisely measured. This is just an aluminum head, probably dimensionally pretty well taken care of. And this is a soft, sort of sticky, where they glued it or adhered it to the end of the tube. This is brand new. I saw it removed from the box. Date code of 4th week of 67. The getter is an enclosed little disc so as not to release anything that would stain the inside of the glass. And this drum contains a bunch of diodes, with the anode probably in the center. Here's what the tube would have looked like when it left the RCA factory. You can see that the current amplification is 1 times 10 to the 6th. I was recently, that is 1995, introduced to this 8072. It's another ceramic beam power tube, and I was asked to fix a RF generator for an Asher, or a plasma generator. It performed in laboratory a function similar to a muffle furnace, although I understand it can do a lot more. I never got the entire unit. I always got just the power, the RF power supply. These were designed for vehicular applications. The voltage for the filament or heater is 12 to 15 volts, which is pretty generally the output of the electrical system in a standard American car. The units I encountered, I never saw one of these tubes in the transmitter. I got a number of these units that had 4 tubes, I believe in parallel. I never got a schematic, and I never replaced a tube. It was always some other component. Operated at 13.5 megahertz, and the units would put out anywhere from 150 to 500 watts. They were intended to be conduction cooled, and for that reason they, on this surface here, staying away from the bottom radius and top, about 3/4 of an inch here, a press-on heatsink that wrapped around with fins sticking out radially was used, and a lot of them were actually beryllium. There were caution signs on the equipment. You can see some signs of white thermal paste here. Now this is the plate or anode. This is the screen grid. And then these pins at the bottom are used for the heater, cathode, and control grid. You'll see that if this is used as a power amplifier for just continuous wave or FM, that typically the plate is 500 to 700 volts, or the anode. and the output power's 85 to 110 watts at 50 megahertz. The date code on this is 9th week of 79. And this tube was not, there's nothing wrong with this tube. The unit was in operation. In fact, I have it somewhere in my shed.